For this one, we have simple interest and effective annual yield. So for number one, suppose your friend wants to invest money into an account that earns 1.2% simple interest for 18 years to save up money to go towards his son's college. He wants to have $25,000 in the account after the 18 years. How much would he need to invest now if he's only investing one lump sum into this account? So here I wrote down below just a reminder in terms of what the simple interest formula is and what our future value for simple interest formulas are. So both of those are different ones that you can use depending on the problem that you're working with. So in this particular case, we are working with simple interest, but we're dealing with a future value because we want how much he needs to invest now if we know how much he wants to have in the future. So in this case, this amount A, this total amount that he wants for the future, is part of what we know. So we know this $25,000 for A, for that total amount, is equal to P is what we are trying to solve for here. The principal, the amount he has to invest now to get to that. And then we'd have the 1 plus 0.012, because we have 1.2% simple interest for that 18 years. And it is just simple interest, not compound interest. So we don't have to worry about anything with those exponents or anything else like we would have if we're dealing with compound interest, times 18. So make sure you are recognizing what type of problem it is. It should say if it's simple interest or compound interest. This one we're dealing with simple interest. So here in this case, if we go through and multiply what we get in the parentheses here, I'm just going to write this off to the side here. We have 1.216. So here, just like any other time, whenever you're going through and trying to solve for a variable, we're going to have to divide that on both sides. So let me write this in a separate step to make it a little more clear. We have 25,000 equals, and then we can put that 1.216, and we can write it as times P, because this is being multiplied by it, and remember, multiplication is commutative. You can switch the order, and you get the same answer. Then it may seem a little more clear to you why we need to then divide both sides by that 1.216. And make sure if your values repeat or keep continuing or anything, make sure to wait to round your answers until the very end, so that way you can have your answer be as accurate as possible. So then we have $20,559.21. Once again, $20,559.21. So make sure whenever you're plugging in these values that you are getting those same answers. If not, make sure that you know how to plug it into your calculators accurately. And if you have questions, make sure to ask. Number two, we're doing something a little bit different. Here we have Tom plans to borrow money for a car loan and is trying to decide which bank to borrow from. Bank 1 has an interest of 3% compounded monthly, and Bank 2 has an interest of 3.5% compounded quarterly. Which bank should he borrow from to avoid paying extra money for the loan? So in that last problem, we were trying to figure out how much he needed to invest in order to get to the $25,000. In this case, we have two different banks we're working with, trying to figure out which one is the better deal. So we can use this effective yield formula, which I have a reminder of what that is down below here. And we'll need to do that for each problem. So the Y there represents your effective yield. So I'm going to put a 1 beside this for bank 1. And we'll have 2 down here for bank 2. So for bank 1 here, we would have 1 plus, make sure to convert that to a decimal once again, 0.03 for the 3%, over n, which in this case it is compounded monthly, so that means 12 times per year, so that would be your n, to the 12th power, and then do whatever that answer is, minus 1 to get to your final answer. So here, if you go through and calculate that, depending on the problem, it will depend on how many digits you should round out to. Some of the problems will tell you what to round your answers to. Here we'd have 0.0304. The more digits you go out, the more accurate it'll be. For bank 2, we'd have a similar process. We would have the 1 plus, in this case we had 3.5%, so that would be 0.035. Over, in this case it was compounded quarterly, so that means 4 times per year. So in for n we would have 4, and then make sure the minus 1 at the end, otherwise your value is going to be more than 1. So here we would have 0.0355. And you could also think of these in terms of percentages. This first one would be about 3.04%. Because remember, you move that decimal point over 2 places to change it to a percent. And this other one would be 3.55%. So quite a bit of difference there. So here in this case, we would have then that bank 1 would be the one that you would want to go to for getting a loan, because then you would have to pay less money. If instead you were looking at investing money into like a savings account or anything else that you're investing into, you would want to look for the larger number instead if you're trying to gain money instead of trying to borrow money. So make sure to keep in mind what the context of the problem is, of what type of value you're looking for a higher effective yield or a lower one. In this case, we wanted the lower one.